Alright, so Clash of Clans and math put together here. So this is U5A7-10 review. Talking about maximizing area, minimizing perimeter, and that sort of thing. So this is Clash of Clans, and each of these things here in Clash of Clans has an area of 3. So I have various items here like a mortar, a wizard, power, and that sort of thing. Not this, but the rest of them have an area of 3. And I want to see what happens if I change the shape. If I have a certain area, so 3, 6, 9, 12. This has an area of 12. These guys have an area of 12. But I just want to show you what happens if you want to minimize the perimeter. So in the game, you have a certain amount of wall, and you try to maximize the use of the wall, or minimize the amount of wall around what you're using. Now, different bases and different strategies are come into play. But let's just look at this in a basic point of view. Look at here where I have these 12 area of, like I said, sorry, these guys have an area of 9. I think I said 3 earlier. They're 3 by 3 squares. So the area of 9 each, so 9, 18, 36 total, right? So area of 36 total, and you want to go around and see how much wall you have to use. So both the same area. And here I have, I've used 34, if you count them, 34 pieces of wall. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, sorry, I double counted the corners. So don't double count the corners. This piece and this piece is 17, and then to here we have 34. So 34 pieces of wall here, and then here let's figure out how many. What is up with that? Never heard that before. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 pieces of wall. So 34 pieces of wall, 28 pieces of wall here, less wall, more efficient. Okay, and that's basically what happens when you try to minimize and minimize perimeter given an area, or vice versa. What you realize is if you have a shape given a certain area, if you want to minimize the perimeter, so here we had whatever it was, 36, 36 was our area. This guy here is going to use more wall and hence more perimeter than this guy here. Okay, and vice versa. If you have a certain piece of, if you have a certain amount of wall, so if I have 28 pieces of wall, let's say, I could make a nice 7 by 7 here figure. We'll have an area of 49. If I get anything that is not square, less square, so let's say I go here, so it's 2 by what, 12, something like that, 2 by 12. That'll be an area of 24. So anything less square is going to get you less area. 2 by 12, if you get to 8 by 6, so if I go 8 by 6 here, well, that's close, but it's not as big, and you can't get bigger. Okay, and then if you go 6 by 8, it goes back to 48. So that's how that works. It also works in 3 dimensions. So if you look at 3-dimensional shapes, okay, so if I have a 3-dimensional shape like this, if it's a cube or if it's a cylinder, it won't matter. What you want to do is get as square or as cubic as possible. So if you have a box, okay, and you want to minimize the amount of packaging used on the box for a given area, or you have a certain amount of packaging and you want to maximize the area, what you want to do is make sure that this guy is as square as possible. So you want this side to be the same as that side, and that side to be the same as that side, etc. And then for cylinders, so that when and then when that comes up in formulas, when you see L's and W's and H's, right, in the formula, don't re-memorize the formula sheet. Let me see if I can get that for a second. Yeah, so if you look at the formulas here, you don't need to re-memorize the formulas. So this is the formula sheet here, EKO formula sheet here. So if you look at the square base rectangular prisms, which will turn into square base prisms eventually, you notice that all these W's and H's will be the same. Now don't rewrite this as 2 and then add these, figure out what this is with all the sides being the same. And same with this here, you don't need to necessarily memorize this. Just know that L is equal to W, which is equal to H when you have an optimal shape. And then the same with cylinders. The cylinder is a little more complicated. The cylinders are a little more complicated. Let's just quickly go back to this real quick. So when you have a cylinder, what you want to do is make sure that that it is as cubic as possible. And what that means is that the height is equal to the width, and the width is the diameter. Now, diameter doesn't come up much in the formulas for, excuse me, for, well, it does a bit, but not so much for the formulas of cylinders. What comes up is radius. So what you have is that h is equal to d, which is equal to 2r, okay? Because twice the radius is the diameter, and if you want it optimized, you want the height to be the same as the diameter, because you want it to be kind of like a cube, right? You want it to be as boxy as possible, as even as tall as it is wide, kind of thing. Okay. So then every time you see a d in the equations, so let's go back to our equations over here. Anytime you see an h in the equations, what you're going to do is replace it with 2r. So this guy here then turns into pi r squared times 2r, and if you clean that whole thing up, it's 2 pi r cubed. Should you memorize that? I don't know. I wouldn't bother. I would just get used to knowing. You won't have that on your formula sheet. You'll have this exact formula sheet here. And again, here you'll notice that this then becomes 2r again, and then when you clean this up, this will be 4 pi r squared. And then you have 2 pi r squared, so 2 pi r squared and 4 pi r squared. That's your 6 pi r squared. That's where they get that in I think it's U5A7-10 or somewhere around there. Okay, I hope that makes sense. You want to make everything as square as possible, as boxy as possible, and that's how you minimize and optimize things. Oh, actually, hold on a second. Let me do one more thing. Let me go back to, because I had some questions about this, about maximizing a square. So if I just have a square, right, we just talk about maximize the area of a square. So let's just say I had, let's go with something nice, 24 pieces here of fencing. And I wanted to figure out what my maximum area is. Well, we worked this out, and we said that it wants to be a square, so you say 24 is equal to 4 times s, because each of these are the same, so each side length is 6. Okay, so 6 and 6 is 36. So 36 meters squared. Then the question is, what happens if I have a house already, and I want to build a fence across the house? And intuitively, you say to yourself, well, then I just make a giant square. But now I'm lucky because now I just have 3 sides, right? S, S, and S. 1, 2, and 3 sides. So what you want to do then is 24 divided by 3, which is 8. And I'm going to make a big square fence against my house here where I don't have to use the fence. And it's going to have an 8 by 8, 64 meter square area. And that makes sense intuitively, but the truth is, it doesn't really work. What happens is, what you find out, what the maximized area is when this guy and this guy are the same length. So let's give this a S, give it S, whatever you want to call it. And this guy is twice as long. Because what happens is you want to make this side, which is parallel to the house, as wide as possible because you get all this free fencing essentially. So there's a balance here. You want it as square as possible, but you also want to move it into a situation where you're getting free fencing, because you get to increase your area. And let's look at this example here. If this is 24, right? This is 24. My S's are, I have 1, 2, 3, 4 S's. Each of these is going to be 6. So again, if I have 24, I'm going to go 6 here, 2 times 6, which is 12 here, and 6 here. Okay, so this now is 6 by 12. Does that add up? 6 and 12 and 6, that's 24. So yeah, I'm not using too much fence. And 6 times 12 is 72 meters squared. So that 72 meters squared is bigger than this. And if you get any skinnier, you use more free wall, but then your area gets smaller because it gets too skinny. So the optimal area here, when you're getting a 3-sided shape, is that the width is double the length, or vice versa. You can call the length the width, or the width. But the free side, the side that's by itself, is twice the length of the 2 sides that are parallel to each other. Okay, hope that makes sense. Take care.